we start part B, networking basics and overview of web programming. The first part B.1, networking basics, IP addresses. All right. So let's look at this picture. In this picture, we are here. So we are using our desktop PC or any client machine. How do we connect to the server? In this example, we use this way to connect to server. We type URL in our web browser and hit enter. Then you send a request to a web server. All right, but the question is how to identify a server. How do you know your request can be sent to one particular server? Yeah, because you can say, because we use the URL will be used to identify the server. Yeah, so that answer pretty close. Yeah, pretty close. All right. But there is a lot of detail behind it. Yeah. All right, so let's look at the communication cycle. Client-server communication cycle. We know client always starts a conversation with a server. It needs to know a special address of the server. Here, that special address, it's called IP address. IP, Internet Protocol. So IP address. But here you can see we didn't type IP address, right? We just use domain name, URL, a long string of URL we type. It's not IP address, right? Yeah, but there is a close relationship between them. Yeah. We will see that quickly. So the IP address is a unique code that identifies a piece of equipment. It could be a computer, some other devices, not necessarily computers, a piece of equipment connected to a network. Some network, we know any network can also connect to internet. Yeah. Sometimes local network, sometimes global network. Okay? Yeah. All right. Regarding the IP addresses, there are two types. One old type, another current new type. The old type, IPv4. So that's the one most people familiar with. That is the old type, IPv4. Now, it is a 32-bit number. 32-bit. 4 bytes. Each byte, 8 bits. So this IP address, this type of IP address, the old style, 4 bytes. Okay? Yeah, here I show you an example. So IP address, here you can see. And the format you can see here also. Yeah. A sequence of numbers separated by dot. Yeah. Another, the second type, IPv6. 128-bit number. Much longer. You can see how many times. IPv4 times 4. 4 times. regarding the bit size 4 times. Okay, regarding the bit size 4 times. Yeah. Our next slide, we will talk about IPv6. Yeah, because it is very complicated. Yeah, IPv4 much simpler. Yeah, IPv6 much more complicated. Yeah. For the number of IPv4 addresses, 2 to the 32 power. Yeah, so you can see approximately 4.3 billion. Approximately 4.3 billion. That many. Yeah. But that number, think about currently there are more than 60 billion people in the world. More than 60 billion people in the world. Already, the resource in IPv4 already run out. Okay? Already ran out. All right? Yeah. Several years ago, already ran out. Okay? Yeah. So that's the reason the second type IP address must be created. Yeah. How many IPv6? So if we calculate in this way, you can see it is this number approximately. 3.4 times 10 to the 38th power. That big. How big it is? Do you know how do we call that number? That huge big number? How do we call it? Yeah. So there is a name. I believe most of you may not know it. Yeah. I do not know it after I see it the first time. Oh, this is a new name for me. Right? 340 undecillion. Undecillion. Any one of you knows this undecillion, the meaning of this word undecillion? How large is it? 1 undecillion equals 10 to the 36th power. 10 to the 36th power. Yeah. All right. That's undecillion. Billion, you can see from billion to undecillion. How many levels do you need to go? Many steps. Yeah. Every step 3 digits, right? You need to jump so many steps. Then you reach the undecillion. Yeah. I don't want to, look at each one, the name of each one. Nobody can memorize that. Yeah. From billion, trillion, zillion, then we get lost. Yeah. All right, that's the IPv4. Next, let's compare IPv4 and IPv6. Yeah. The communication model is like this. Based on this communication model, we focus on the IP address part. Yeah. The properties of IPv4. Yeah. People try to make it human readable. Yeah. Because usually, so think about how do you make it human readable? How do you make 32-bit number human readable? Think about, suppose when you write a 32-bit string, 0, 1, 1, 0, 32 0 1s put together. Nobody can memorize it. Nobody can memorize that 32-bit string. Yeah. So people try to make it relatively easier to memorize. How to do it? Yeah. Using this way. Divided the 32 bits into 4 blocks. Each block 8-bit number, but 8-bit number can be represented as a decimal number between 0 and 255, right? So that number, decimal number, relatively easier to memorize. Relatively easier to memorize, although still not quite easy, but at least much easier than you try to memorize a 32-bit number. Yeah. So that's why we call it human readable notations. Yeah. And specifically, IPv4, it is a dot decimal notation, using dot as the delimiter, and each block is in decimal representation. Yeah. All right. Consisting 4 decimal numbers. Yeah, that's the range. That's the range for 1 byte number. Yeah. Then private networks. So when we use IPv4 addresses, we can represent, various types of networks. Private networks, approximately 18 million. Remember, the total number of IPv4 addresses, 4.3 billion. Inside 4.3 billion, 18 millions are used for private networks. Private. So remember the private. Okay, so people in your organization or at your home. At your home, you have a private network. So many people set up networks at home, so private networks. In company, so many companies, they have their internal intranet, that's also private networks. Yeah. Multicasting addressing use 270 millions. Another block of resource inside that 4.3 billion. So you can see, removing these two parts, the remaining approximately 4 billion. The remaining number of IPv4 addresses can be used for regular networks, approximately 4 billion. Yeah. Static IP addresses. From the name, it does not change. As soon as you get that IP address, it is fixed. Yeah. So that's a precious resource, because after you have it, it is fixed. Yeah. Very important resource. Yeah. Static IP addresses, usually if you have a server, you want to have a static IP address. Yeah. So then you can provide stable services to the outside world. Yeah. Right. But because the static IP address is very precious, so then people want to save this kind of resources. Yeah. So there is another type of IP address called dynamic IP addresses. Then you can see from the meaning, from the word meaning, they may change frequently. Yeah. Yeah. Usually, the dynamic IP addresses for our individual users, yeah, when we surf the web, usually we use dynamic IP addresses. Yeah. We need IP address, yeah. But the IP addresses we use can change occasionally. Yeah. How frequent? So it depends on the situation. Yeah. The reason to do that, because you do not use that IP address all the time, right? Sometimes you use, sometimes you do not use. So for that reason, your ISP, your Internet Service Provider, ISP, internet service provider will allocate a dynamic IP address to your computer. Yeah. All right. If you do not use it, then your ISP can assign that IP address to a different user. In other words, many people can share this kind of important resources. So dynamic IP addresses. Because yet you do not use servers. You do not, for that kind of web surfing, you do not use for your servers. So that's why you don't need a static IP address. Yeah. All right. Private IP addresses. For private networks, you use private IP addresses. So usually they are not unique. So what's the meaning? They're not unique. Yeah. Because within your home, you use this IP address 192.168, for this kind of thing. Everyone at their own home, you always use that. Yeah. I use this at my home. You use that at your home, right? So that's not unique. So many people use the same IP address for their private networks. Why? There is no conflict because it's private to your own region. You do not use that. You use this to communicate inside your own network. You do not use this to communicate with the outside world. So that's why you are fine. That's the private IP addresses. All right. The public IP addresses, then this kind of IP must be unique because people need to use the public IP addresses to identify, to locate individual equipments on the internet. So must be unique. Yeah. So then you can see for these different types of IP addresses, there are a lot of meanings behind. Yeah. All right. Next, IPv6. So this time, the very complicated IPv6. So let me just give you some very basic information. We cannot get too much details. Yeah. All right. Properties of IPv6. First, the format like this. This time you can see we use hexadecimal representation. Not decimal, hexadecimal. I hope you know the structure of hexadecimal. So here I do not repeat it. Yeah. All right. An IPv6 address made up of 128 bits. Really long. Okay. Really long. First, if we just show the original 128 bits, how can you memorize it? There is no way anyone in the world, probably someone in the world, because I know some people can, memorize long decimal positions of pi. Remember the competition? Yeah, I heard of, some students can, memorize as many as 2,000 digits of pi. Yeah. So if you want to try, you can, but I believe for 99% of the people, you cannot memorize it. I cannot. Okay. All right. Then, in order to make it relatively easier to, to view, still, after we try to make it easier, still hard to memorize. So I just say to view it. All right. break into 6-digit hexadecimal numbers. Oh, 4-digit hexadecimal, right? 4-digit. So look at this, 4-digit. All right. Here, the digit means hexadecimal digit, not decimal digit. Okay, hexadecimal we call it digit. Yeah. Each digit there are 16 digits. Okay. From 0 to 9, 10 digits. Then from after that, A, B, C, D, E, F. 6 more digits. So total 16 digits. The hexadecimal notation. All right. Yeah. So then the representation we called. Yeah. So here we called. Yeah. Colon. We use colon as the delimiter. Colon separated hexadecimal numbers. So colon hexadecimal notation. So we use colon hexadecimal notation. IPv4 we use dot decimal notation. Here, colon hexadecimal notation. All right. Simple example here. Yeah. You can see each block. How many blocks do we have? Each block 16. Okay. Yeah. 8 blocks, right? 8 times 16, 128. So 8 4-digit hexadecimal blocks. That's the structure. Yeah, here. So we call it colon hexadecimal notation. All right. Then there are some rules. Here I just give you some the relatively simple part. I do not want to, give you all the rules. We don't need. We just get some sense of this kind of notations. The first rule: discard the leading zeros in each block. In each block, if you see some leading zeros, for example, 0, 0, 1, 2, okay? So you can discard the leading zeros. Yeah, so we get used to it. Yeah, so that's fine. Yeah. For example, in this expression, there are many leading zeros in some of the blocks. So we can, here we apply this rule. So you can see the change from that. Yeah. But you can see we didn't do that change here, although we can, right? It's perfect, fine. You can apply the rule on other blocks. You're fine. Yeah. Let's see some other rules. The second rule: if 2 or more blocks contain consecutive zeros, here we have some consecutive zeros, right? Omit them all. Yeah. So you try to make it as compact as possible. Omit them all and then replace with double colon sign. Okay. So one way to make it compact. All right. Example is this. Yeah. Here we have this consecutive blocks with 0. Yeah. So we replace by nothing between 2 adjacent colon signs. So that's that case. All right. Yeah. So then there is another place here, right? Yeah. Rule number 3. Consecutive blocks of 0 can be replaced only once here. If you have several places, we only apply this rule once. Otherwise, we may get confused, right? So the reason of that is because think about, if we are allowed to apply that rule multiple times, people may get confused. How do I recover the original form? Can you translate it to the original form? No, ambiguous. That representation is ambiguous. In order to avoid that ambiguity, we have to enforce this third rule only once then no ambiguity, right? Then no ambiguity. Right? All right. Okay. Yeah. But if there are still blocks of zeros after we apply one place, one location, still, consecutive 0 blocks, then we shrunk down by 0. Yeah. So 4 0 bits shrink to 1 0 bit. So that's our first rule. Rule number 1. Okay? Yeah. Then there is no ambiguity, but at the same time, we make it as compact as possible. Yeah. All right. The example is this. Yeah. So now for this block, we replace it by 1 0 bit. 0 digit. Here we'd better call digit, not bit. Bit we only mean 0 or 1. Yeah. But here it is a hexadecimal digit. All right. So these 3 rules. Okay. Yeah. So we only learn these 3 rules. Yeah. So we get some idea of this IPv6 addresses. Then the structure, one part site prefix, divided into several parts. A site prefix, the first 48 digits. Okay? Yeah, leftmost bits. Yeah, here. But it's better use digits. Okay? Yeah, maybe some people call that. Oh, okay. Sorry. Yeah, because this here bits is okay because we are talking about a 0, 1, right? Original 0, 1 form. So then it's bits. So that's fine. But if we talk about these things, should be digits. So bits here, digit there. All right, so no problem. Yeah. All right. Okay. So it's called the public topology of your network. Public topology. Yeah. Okay. Yeah. The second part, subnet ID 16 bits. 1 block, because 1 block corresponds to 16 bits. This part. Okay. Internal topology of the network to a router. So that's the private network part, internal. Yeah. So it's enough. 1 block cover that type, so it's enough. Yeah. Number 3, interface ID. Yeah. The remaining bits or digits, the remaining. Yeah. Interface ID. The more details regarding, so we do not need to know, okay? Because that should be enough. We just want to get some very basic information. All right, that's for the part B.1.